I became interested in human disease when I did biology at school. There were many people in my family who were already in the medical profession. So when I finished matric, I was very clear that I wanted to study medicine, and then did a short stint in general practice for about 3 or 4 years. Then decided I wanted to work with more complex disease, and so I went to train in internal medicine. And this all happened during the terrible time when HIV rates were going up and antiretrovirals were not available. And I saw hundreds of patients who frequently had respiratory infections, very commonly tuberculosis. And so I became interested in respiratory infections, particularly TB. And I ended up here at the University of Cape Town. We established a research lab here. Then, of course, I got the Harry Oppenheimer Fellowship Award to study some aspects of drug-resistant TB. You know, this is one of the most prestigious research awards in the country. And I was delighted that the award had been made to study a disease of poverty. So the research I did with the foundation focused around the problem of drug-resistant TB. Interestingly, there's a small proportion of individuals, maybe 10 or 20% only, that transmit most of the disease. We wanted to better understand who were these people spreading drug-resistant TB. Could we identify them? And could we learn more about them so that we could design transmission interrupting strategies? And we used a novel technology called cough aerosol sampling technology. So we got patients with drug-resistant TB and drug-sensitive TB to cough into a special device. This cough aerosol sampling technology gave us the ability to enumerate the number of infectious organisms that people coughed up. So that was the metric by which we could measure infectiousness. The first thing we discovered was that, contrary to popular belief, drug-resistant TB was as infectious as drug-sensitive TB, and therefore we should take it as seriously as drug-sensitive TB. The second really interesting finding we had in the study is that we found that individuals that were highly infectious versus those that were not, the genetic code of the bug wasn't very different. And that is quite an important finding because it means we need to look elsewhere. It's probably human genetics, or it could be epigenetics. So those were two very important findings. And this work, funded by the foundation, was in fact published in a journal called Nature Medicine. The foundation award had a fundamental influence on my career over the last 10 years. Most influential was really the understanding that the best way to abrogate transmission was to find and treat patients with drug-resistant TB and drug-sensitive TB early on. That means really going out into the community and finding TB patients. So we've now created a scalable model. You can much more easily find it if you take the diagnostics out into the community. We are conducting extensive studies on how best to optimize this model, how to abrogate infectiousness, how to find these individuals early on. And so that's an example of some of the studies that we're doing right now. And you can see the link with the work that we did with the foundation. That's really been influential in terms of what we're doing now.